In this video, we're going to be talking about quadratic functions. Specifically, we're talking about identifying features of a parabola, which is this U-shaped graph, which all quadratic functions will take on that shape. Okay, so to start, the vertex of a parabola is the turning point of the graph. So this parabola opens up. So first we have this section that's decreasing where it switches to an increasing graph. That is the vertex of the parabola. So the vertex in this case is a minimum point on the graph. The vertex could also be a maximum if the parabola opens down instead of up. But specifically, this vertex is located at 1, -4. The axis of symmetry is a vertical line. It's a reflection line on the parabola. So if I were to draw a line right through the vertex, a vertical line right through the vertex, and I were to fold the left-hand side, it's going to lay right on top of that right-hand side of the parabola. So that axis of symmetry is always going to intersect the vertex, and specifically the vertical line is going to have the equation x equals, and then whatever the x coordinate of the vertex is, in this case 1. All right, the x-intercept are the points where the parabola touches the x-axis. So in this case, there's 2 of them. And they have the points -1, 0, and also 3, 0. So we name these as a coordinate, x and y. And the y value should always be 0 if we are on the x-axis. The y-intercept is the point where the parabola touches the y-axis. So if we look, this one touches the y-axis at 0, -3. Again, if it's a y-intercept, the x-coordinate will always be 0. And then we have 2 intervals for every parabola. We have a decreasing section, and then we have an increasing section. We name these by the x values. So the vertex is the turning point of the graph. So at the vertex, it's going to change from either increasing to decreasing or decreasing to increasing. So if we move from left to right, and I were to trace over this parabola, notice that my mouse here is moving in a downhill fashion. So this first section of the graph is decreasing as I move from left to right. So I would name these by the x coordinate, and if I look specifically at this x-axis, I can change colors. This part of the x-axis is where the parabola is decreasing in value. So I would name those by -∞ to 1. So that's interval notation. So this is saying from -∞ to +1, the graph is decreasing over those x values. Notice my value of x is the same as the vertex value. Okay, then if I trace over my parabola on the right-hand side, so from the vertex moving to the right, notice that it's going uphill. So this is an increasing interval. Oh, I just reversed this. This was my decreasing interval. Sorry about that. Increasing interval is the right-hand side of this graph. So it starts at +1 and goes to infinity. So this section of my x values are where the parabola is increasing. So from 1 to +infinity is where it's an increasing interval. All right, let's take a look at another example. In this example, notice that the parabola is opening down instead of up. All right, so to get started, let's take a look at where that vertex is located. That's the turning point of the graph. So on this parabola, it's located right there. That has the coordinate -3, -1. Drawing in that axis of symmetry or the reflection line, again, it's always going to go through the vertex of the graph. That has the equation x equals whatever the x value of your vertex is. So x equals -3 is where this axis of symmetry is located. The x-intercepts, if we scan that x-axis, notice that this parabola does not touch the x-axis at all. So there are no x-intercepts. The y-intercepts, if I look at the y-axis, this parabola is going to touch the y-axis at, it looks like maybe -9. It's off the graph, but I'm going to guess it's 0, -9. Okay, those intervals, if I run my mouse over the left-hand side, notice that this time it's increasing first. So it's increasing during these x values. Make sure I put this in the right spot this time. So from -infinity to -3 is where it's increasing. Then it switches to decreasing on these x values. So from -3 to +infinity is where the parabola is decreasing. All right, another example, we have a parabola. This one again is opening up. Like the first example, that vertex is located at -1, -2. The axis of symmetry goes right through that vertex and has the equation x equals -1 in this case. It does intersect the x-axis. They do not intersect at whole numbers. So I'm going to just be estimating in this vertex, or in this video. We will talk about how to find those exact locations a little bit later. So I'm going to estimate that first x-intercept is at -2.50. And the second one, I'm going to estimate that that's at 0.50. All right, the y-intercept, this parabola crosses the y-axis at 0, -1. Looking at those intervals, the first section of my graph is decreasing. So for these x values, it's a decreasing interval. So from -infinity to -1, it's decreasing. And then from -1 to +infinity is where the parabola is increasing. So these x values.